Today's job is to integrate a bunch of source trees into a backbone phylogeny, and this is for Lepidoptera, moths and butterflies. Now I've just finished a phase of collation of source trees. So I have something like 50 source trees here. It's taken me three or 4 weeks or something to collate all these. So about 50. Eventually, maybe nice to have something in the range of maybe 200, but I think this is okay for the time being. So what I'll need to do now is rerun the analysis. These source trees are going to be grafted onto the transcriptome backbone topology for Lepidoptera. Now, I've done this once before, just to see where the gaps are for the source trees. So I need to do this again and see if there's any remaining major gaps, and if there are, then I get a few more source trees. If not, then I go ahead with the downstream analysis. But for now, I will need to make some minor changes. Particularly, I will so this is a list of source trees. So these are a list of file names corresponding to a published source tree of Lepidoptera. And previously, maybe I ran this with about 10 or 20. Now I've collated more, so I need to put all the list of file names I have now into this first job. So here's a table where I record all the details of the source trees I've databased. In some cases, these have been made available as a machine readable tree alongside a publication, and I denote that by processed, which the trees usually virtually always still need some further processing. But a lot of times people don't even make it available, so I'll do some manual transcription of the file, of the phylogeny. All the details of these source trees, and I just need the names. I've saved them into a file here. Okay. So a list of file names put into the object just called a bash variable just called source trees. I think we're in the correct directory already. So copy this object into the shell. I don't need this anymore. Okay. So firstly, we have a loop. This loops through all items or all indices of the source trees object here, and for each index it pulls out the item assigned in that index, puts that into a variable named file, and then cp copy from where the file should be held into the working directory, which is a different one. So just copying the files. Should look for error message, see if it hasn't found one of them, but looks fine. So Lepidoptera grafting stage 1. this might be done multi-stage. So in this case now I've got a few more, maybe about 50, then I may try 2 stages of this with grafting. So we need to make a new variable with the source tree list, which is just as a string as opposed to say an array here. So delete the old list and put in updated. Okay, so we're running a script, relational constraints, and here's the option graft source trees and the variable list the file names of the source trees in here. So that initiates the grafting algorithm in this script. Other input files, this is a colon alignment, omics backbone, and a taxonomic database for Lepidoptera. We remove any previous output files. Just noticed names, these are the old names. Okay, that should be fine. Let's try this. Then we should have a okay, here we go. User opted for grafting algorithm, made 38 subtree grafts, totaling 1259 terminals. Okay, let's make a copy of this. Unfortunately, I didn't make a note of the result after the previous run, which would have been, of course, a lot less, but still nice to know what the numbers are. So I'll put a date on and what the change. Okay, so we'll try another stage of this, see if we get any more grafts. What we need to do here is actually implement like a search for this, because currently I'm just maximizing even. So when you're matching taxa of the backbone to taxa of the source trees, there'll always be different options. A given taxon will be present on multiple source trees, so you need to make a choice. Currently I'm just maximizing the number of species, which is not even ideal. I should maximize taxonomic diversity firstly, but also I think there needs to be done as a search, like randomly assigning and then doing multiple stages of grafts. So I'll do that. at a later stage. Anyway, for now we'll just have 2 stages of grafting. Okay, so the main thing is the backbone. Instead of using the omics backbone, we're using the previous grafting result. Now we need to remember to read in the source tree list. Co1 matrix, that's going to be the same. Taxon table. So here's the grafting results from the first iteration. And I'll just use this newer one. Maybe slightly different. Yeah, I noticed have an option to, I don't remember what, is this the out group maybe? I presume that's the out group. Hopefully I've noted this. Okay, so yeah, this is a Trichoptera, so this is the out group to Lepidoptera. I'll just point that out here. Just make a note of that here. Okay, that should be fine. Let's try this. So this is a second stage graft, because there might be some grafts onto previous grafts. You never know. Yes, that did happen in Diptera. This all depends on what is present on the backbone and the source trees. This one's a bit slower because there's a lot more on this backbone, because it's had a bunch of stuff grafted in it. So let's wait a minute. Yeah, we've still got some more grafts on the second stage. So that was worth trying. So we'll change the names of the output files. Right, so we've done a bunch of grafting with a new set of source trees. What I need to do now is see if there's any remaining major gaps when we try and integrate the co1 barcode data. So what I mean by this is, so for each terminal of the backbone tree, which now has a bunch of source trees grafted onto it, each terminal will infer a higher taxa, Now that process depends on the comprehensiveness. So there could be cases where there's only a single terminal for only a single representative of a single family, and there's a lot of CO1 data for that, and I would regard that as a large gap which needs to be filled by getting a new source tree for that family. So to identify gaps, we'll run this script, same script as here, but running a different algorithm but not doing the grafting algorithm. Instead, we're trying to just integrate with the CO1. Okay, that looks fine. Let's just try this. Okay, here's the tree integrated with the available CO1 data. And I still see a couple of gaps. Only got 3 now. So we need to find a source tree for each of these 3, because it's a lot of CO1s which will be relying just on the CO1 data to resolve the relationships, and you can't expect too much from CO1. There's not much information content, so we need 3 more source trees to correspond to these three taxa. But that's enough. That's no other major gaps. So one more short round of source tree compilation should do it. Okay, so job done with integrated set of source trees and identified some gaps.